All right, so we've been factoring polynomials. I went through several examples of finding zeros using factoring and getting zeros. And I went through another one about grouping, but what I'm really doing is we're always finding zeros. In example 2, we wound up with two imaginary zeros, or we'll call them roots because we got to start calling them roots because we have imaginary ones. We wound up still with 3 answers. And then in example 4, this example we have a fourth power, so we can get 4 different roots. But then we get to this one, and x cubed plus 8 should have 3. So we talk, okay, how do we solve perfect cubes? So we listed all the perfect cubes, 1 cubed, 2 cubed, 3 cubed, 4 cubed, 5 cubed, 6 cubed. And we looked at what they were, and then we thought, okay, now we can take cube roots, since we know the cube roots of these perfect cubes, right? So then we have the cube root of 1 is 1, cube root of 8 is 2, cube root of 27 is 3, cube root of 64 is 4, cube root of 125 is 5, cube root of 216 is 6. Okay, now these are the perfect cubes. It only works for these numbers, okay? So we talked about, okay, how do we factor perfect cubes? So we looked at, here is a formula for factoring perfect cubes. If you have a cubed plus b cubed, a perfect cube plus perfect cube, it factors into a plus b times a squared minus ab plus b squared. And I put that on the board right over there. So we took a look at an example. X cubed plus 8. Well, what you need to do is rewrite it in the form of a cubed plus b cubed. So we already know that's the same thing as like a x cubed, but 8 is the same thing as 2 cubed. Okay, so we have a cubed plus a b cubed. So we're going to let the x be the a, so we'll plug that in there, and we'll let the 2, not the 8, but the 2, because it's 2 cubed, the 2 be the b. So then all I have to do is plug these into the formula. So I'm going to put x in for all the a's, so instead of a plus b, it's going to be x plus 2. I did that. And a squared would be an x squared, so I'm plugging the x's into the formula. ab means to multiply those two, so I get a negative 2x, plus b squared, which is plus 2 squared, which is 4. That's it. It's factored, okay? Then we looked at another one. Okay, well, what if it's subtract? Same formula, except for just the signs are different. Instead of it being plus minus plus, a cubed subtract b cubed is the same thing as an a minus b, a squared plus an ab plus b squared. Okay, so how does this formula work? Okay, so we looked at another example. If we've got y cubed minus 125. Now again, we got a perfect cubed, y cubed, minus another perfect cube, because 125 is 5 cubed. So we're going to let the y be the a value, or let the 5 be the b value. So we're going to plug both the y in for the a's and the 5 in for the b. So we just rewrite it. So if a minus b, now it's going to be y minus 5, because I plugged the y in for a and the 5 in b. Then a squared is to take the y squared, plus, it says ab, that means to multiply those two, so I get y times 5 is 5y, plus b squared, so if b is 5, b squared is 125. That's it. Now, let's use this. So in our last question that we were taking a look at, on the other page, we said, okay, well, we know there's got to be 3 roots. There's got to be. So we factored. Here's we let that be our a, and we know that that is the same thing as 2 cubed, so we got x cubed. We have 2 cubes, so we have an x and 2 for a and b. We just plug them into our formula, okay? So we plug them into our a plus b, a squared minus ab plus b squared. Okay, so we plug x and 2 in for this. So it's going to be, instead of a plus b, it's x plus 2 times x squared, because a squared minus ab, which is going to be a 2x, plus b squared is 4. Okay, so from here, if I really want the zeros, I've got the first one's easy, negative 2. If I just do my mini equations, x plus 2 equals 0, solve for x, and I get negative 2. Now the other ones, we know because it's x squared, we should have 2 answers. So I have to use the quadratic formula. It will not factor, so I use the quadratic formula. Negative b plus minus b squared minus 4ac all over 2a. Okay, so then, all right, here is, for this, here's a is 1, b is negative 2, and c is 4. We're not doing that anymore, okay? We're just using the quadratic formula. So we've got a negative 2, so I got minus b, which is minus minus 2, plus minus squared of b squared, which is negative 2 squared, minus 4ac all over 2a, and I just simplified it. I got down to here, and I got a negative 12, so then I know I'm going to have an I, so I start breaking down the square root of 12 into square root of 4, square root of 3, and square root of negative 1. Gives me a square root of 4 is 2, and I get an I here. Square root of 4 is 2, and I get an I here, so I've got 2 plus minus 2 square root of 3I over 2. And finally, I can reduce my 2's and have a 1 plus minus 1 square root of 3I. So I do have three answers, negative 2, and 1 plus the square root of 3I, and 1 minus the square root of 3I. So that was the lesson today. There's homework that went along with it, so if you have any questions, come see me.